Welcome back. So today let's have a session on dipole moment. In my previous session we have discussed extensively about hydrogen bonding. Hydrogen bonding and dipole moment are two potential topics in chemical bonding chapter. So let us see all about dipole moment. So what is dipole moment? Dipole moment is associated something with a bond polarity. So dipole, you all aware what is a dipole is all about. So dipole is as follows. So this is a dipole, agreed or not? So what is a dipole? With a positive charge and a negative charge. This is a dipole. This is electric dipole. Okay. Let us see what is a chemical dipole. Okay. Yeah. Well, the dipole moment arises. Let's see the definition of a dipole moment. The dipole moment arises in any system where there is a separation of charge. I have shown you the separation of charge. This separation of charge is going to give or offer ionic character to a particular compound. So the concept of ionic character or ionic nature is inducted to a particular system or a compound or a molecule by virtue of its charge. So this is what exactly. So that means you can calculate the percentage of ionic character. Try to understand, students. No bond is pure. You can't find a pure ionic bond or a pure covalent bond. Most of the systems are polar covalent bonds, or I mean to say they are partially ionic. Or how much extent a molecule possesses the ionic character, that is, the percentage of ionic character can be calculated by using this dipole moment concept. So fundamentally, students, have a look here. If you take a system, so let us wipe off this stuff. For example, let us take a system like HCl. A simple system you can take HCl. Agreed? Students, you know very well why the concept of dipole comes here. Because of difference in electronegativity. You know the electronegativity of hydrogen is 2.1 and chlorine is 3.0. Agreed or not? Yeah. You know very well Xi A minus Xi B is greater than 1.5. It results in the formation of a ionic bond. Or when Xi A minus Xi B is less than 1.5, it results in the formation of a covalent system. You know very well. When Xi A minus Xi B is equal to 1.5, it is 50% ionic and 50% covalent. So the electronegativity Xi is the electronegativity, and the electronegativity difference is more. It leads to the more ionic character. That is the fundamental understanding associated with the dipole moment concept. So let us see here. See, there exists a polarity delta plus and delta minus due to the electronegativity difference. Students, the dipole is basically represented by using a pointed at arrow. And this arrow mark should be on the more electronegative side, and the tail should be on the less electronegative side. Students, try to understand. So if you observe, it is a measure of the bond polarity. It is a measure of bond polarity, and the polarity is basically understood by means of percentage ionic character. What's it? It is a percentage ionic character. Ionic character. Now, definitely the electrical dipole moment is a measure of separation of negative and positive charges. Well, so what is how mathematically you can represent the dipole moment? It is very simple. Mu is a dipole moment. So it is represented by dipole moment is represented by mu is equal to E into D. Very simple formula. What is E? E is the charge separation. D is the distance between two atoms. Students, it is the charge and distance between the two atoms. See, for example, you have a HCl. This is the bond. HCl. Try to understand. So charge delta plus, delta minus, and distance of separation. This is the distance of separation. I can say this is as d, small d, distance of separation. For example, if you take a water molecule like this, you know very well this is delta plus, this is delta plus, this is delta minus, delta minus. Here charge is more here. I hope you understood. Oxygen is -2 and H plus. I hope you understood. So charge into distance of separation. It is the product of distance of separation and the electronic charge. That is how the dipole moment is defined. It is nothing but how it is defined. Students, mu is equal to E into D, and it is expressed, the unit is debye. What is it? Debye. Debye is the unit of dipole moment. So this is the basics of dipole moment. So let us move on to the next slide. Yeah, well, now I am going to teach you dipole moment of different systems which you have learned in hybridization concept. Now, students, have a look here. I am going to start with sp hybridization. Students, have a look. BeF2. BeF2 is a symmetrical molecule. Mind you, students, any symmetrical system, any symmetrical molecule, you can say, students, mind you, remember, mu is equal to 0. Mu is equal to 0. Dipole moment is 0. Dipole moment gets cancelled. Dipole moment gets cancelled. You can see here a dipole is pointed towards one side. Here the dipole moment is pointed towards the other side, and the dipole gets cancelled, and the net dipole is 0. That means, students, this is a non-polar molecule. It is a non-polar molecule or non-polar system. Mind you, students, if it is a non-polar system, what happens? Very interestingly, it is not soluble in water. Interesting, very interesting. It is insoluble in water. So because it is water is polar. And here when you add a non-polar system, it is going to affect. So the bond polarity is going to affect the solubility. Even there is a bond polarity, because here 4.0, this is delta minus, this is delta plus. Here also there is a delta minus, there is a delta plus. There is a bond polarity is there here. Individually there is a bond polarity. Overall molecule it is 0. Mind you, students, again I will explain in another slide. Students, let us take here BeH2 or BeCl2. Have a look. BeCl2. If you draw the bond polarity, it is as follows. You can draw this way. You can take another color which is more visible. I take the black color. So you can see here bond polarity, it is 0. It is getting cancelled. But individually this is polar bond. It is a polar bond. Individually this is also a polar bond. There is a bond polarity. Students, mind you, but if you consider the system, whole system, mu is equal to 0, because it is a non-polar system. Try to understand, students. In both the cases, that means all these three cases. What are the three cases? Let us take a white background. Students, have a look. Let us take here BeF2, BeCl2, BeH2. These systems are basically symmetrical. And for the symmetrical system, overall bond moment or bond polarity is 0. Dipole moment is 0. I hope you are very clear. Now, let us take here another example, a simple example. Let us take here CO2 molecule. Students, what is the structure of CO2 molecule? It is as follows. If you take here the CO bond, there is a bond polarity delta minus and delta plus. Do you agree or not? Individually it is polar, but overall molecule is considered. This is bond polarity is operating this side, this is operating this side, and mu is equal to 0. And CO2 is a non-polar molecule. CO2 is a non-polar molecule. Mind you system, mind you students. Similarly, you can take another one, that is same thing, CH2 also, because CH2 and CO2 both are isostructural. In both cases, dipole moment is 0. I hope you are very much convinced with some of the systems which have sp hybridization. In sp hybridization, you have a linear setup. Its molecule is linear. Students, but have a look here. Let us take here sp2 hybridization. What hybridization? sp2 hybridization. Students, in sp2 hybridization, let us take an example of BCl3. Well, BCl3 is basically a trigonal planar system. Do you agree or not? Trigonal planar system. If you see the individual bond moment B and Cl, there exists a dipole. This is delta plus, this is delta minus. There exists a dipole here. But if you see the overall bond polarity, it is as follows. Naturally, the bond moments gets cancelled because you have studied the subject of vectors in physics, and here the net dipole moment is 0. So net dipole moment is 0. So naturally, so this case mu is equal to 0. You all aware BCl3, BH3, BAlCl3, these are all isostructural. In all these cases, students, mind you, dipole moment is 0 for all these cases. So sp2 hybridization, trigonal planar structure, TP, trigonal planar structure, what happens here? So dipole moment is 0. Well, let us move on to the next slide. Students, you have seen SnCl2. It is also having sp2 hybridization. I don't know whether you remember or not. sp2 hybridization. So let us have a look at this. Okay. So Sn, you know very well, Cl, and there is a lone pair. Mind you students, there is a lone pair. Now, this is the dipole. Agreed or not? But here, lone pairs are, help me, lone pairs are non-directional. That's why dipole moment is non-zero. When dipole moment is non-zero, it is a polar molecule. What molecule? It is a polar molecule. Try to understand. So that means all the molecules having the bent structure are angular shape or V shape. So naturally, all these things, dipole moment is non-zero. I hope you are very much convinced. So with sp2 hybridization, that means electron pairs are 2, 3, bond pairs are 2, lone pair is 1. It leads to a bent structure having a dipole moment, a non-zero dipole moment, and that means the system is a polar system. Well, let us work out another system, sp3 systems. So sp3 hybridization. Now, in sp3 hybridization, you know very well, it is a trigonal tetrahedral structure. Do you agree or not? This is a tetrahedral structure, mind you. So like CH4, SiH4, GeH4, similarly CCl4, SiCl4, I hope you understood, GeCl4. So all these systems. So what happens? The net dipole, for example, if you take in this case C, Cl, 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 Cl. In this case, there is a symmetry. It is a symmetrical molecule. Any symmetrical molecule, the dipole moment is 0. It is a dipole moment is 0 because the molecule is symmetrical. The molecule is symmetrical. Students, I am going to give a unsymmetrical system. CH2Cl2, CHCl3, CH3Cl, CH3Cl. Now, students, CH, Cl, Cl and Cl. Here CH2Cl2, right? So, here CH2Cl2. Now, CH2Cl2. Now, CHCl, Cl, Cl, CClH. Mind you, students, as the molecules, all these molecules are unsymmetrical, dipole moment is non-zero. Dipole moment is non-zero because they are all asymmetrical. They are not symmetrical systems. Now, my homework is write the order of dipole moment. Which case it is more, you have to write it. So I hope you do it. This question is asked in complex examination, all these things. Okay. Now, let us take another system. Let us take ammonia. What is it? Ammonia. You can take ammonia, PH3, ASH3, SBH3 and BiH3. All these systems you take. Students, mind you, you know very well these are having what hybridization? sp3 hybridization. What structure? Pyramidal structure. What structure? Pyramidal structure. They are having pyramidal structure. Now, here also there is a problem. What is the problem, students? The problem is there is a lone pair. There is a lone pair. Lone pair is moving this direction. So, lone pair is non-directional also. Definitely, it is non-zero and it is polar. It is polar. That is the reason why ammonia is soluble in water. What happens? Ammonia, we take another color. Ammonia is soluble in water. So, you can see here NH3 plus water, if it reacts, it forms NH4OH. It is polar molecule. NH4 plus and OH minus. So, I hope you are very clear about so a system having a pyramidal geometry and naturally is going to be a polar system. Now, let us take here. Now, I would like to give an example of NH3. One second. Let us write the system properly. NH3 and NF3. So, this question is asked in the complex examination. So, which case dipole moment is more? Very simple. Students, write the bond moments properly. Which is more alto negative? Nitrogen, hydrogen, nitrogen. Nitrogen, hydrogen, nitrogen. So, arrow should be towards the, and always lone pair should be up. Agreed? So, all bond moments are projecting one side. Agreed or not? Now, nitrogen and fluorine. Help me. Nitrogen and fluorine bond moment will be towards the fluorine side. Towards the fluorine side. Towards the fluorine side. Here, towards the lone pair. Here, the bond moments gets cancelled. Naturally, what naturally? Ammonia is greater than NF3. This question has been asked many times in the competitive examination. So, the dipole moment of NH3 is greater than NF3. Very, very important. I hope you understood. So, here the bond moments are getting cancelled. Here you can see this bond moment is up here. This bond moment is down. This is getting cancelled. I hope you. Only 2 bond moments are additive here. Here 4 bond moments are additive. 4 bond moments are additive. Let us take here the next case. What is this? It is a water molecule. Water molecule is having 2 elephant ears. What is the elephant ears means? 2 lone pairs. Agreed or not? It is looking like elephant ear. two lone pairs. Now students, just try to make an attempt to see the dipoles. So towards water, towards oxygen. Here also, I hope you understood. Naturally, you know very well water is a polar molecule. Dipole moment is not zero. It is a polar molecule. Everybody you know, and it has a dielectric constant. Dielectric constant is a measure of polarity. Is a measure of polarity. Dielectric constant. Okay, because it is whether the given system is an insulator or not. How do you know? It is known by using dielectric constant. So I hope you are very much convinced with this. Now, students, now what is your understanding so far? It's pretty simple. If the hybridization, if it is having a regular geometry associated with the hybridization, then naturally such a symmetrical systems, so dipole moment is zero. If it is irregular geometry, that is having lone pairs, whenever there is a lone pair, so dipole moment is non-zero, and that leads to polarity. So more is the polarity, more is the soluble in polar solvents. More is soluble in polar solvents like water, methanol, acids, etc. Now let us have a look at the next thing. Now let us take student PCl5. What to take here? PCl5. This is a pretty important question. So PCl5. Yeah. Students, have a look. This is P, Cl, 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 Cl. Yeah. PCl5 is symmetrical. Why it is symmetrical? I'll explain here. Have a look. Students, this is symmetrical and this is symmetrical. Do you agree or not? So trigonal planar structure already you're done. Trigonal planar structure, it is symmetrical. Linear also it is symmetrical. Here also it is getting cancelled. And here also trigonal planar system, it is getting cancelled. So in this case, naturally mu is equal to 0. Mu is equal to 0. Try to understand. Now, next case. So let us take here the case of SF4. SF4. Yeah. In SF4, it is having a structure called seesaw. What is it? Seesaw structure. So if you draw the seesaw structure, it is having something. What is that something? It is having a lone pair. So naturally, so when the lone pair is there, the molecule definitely is going to be a polar molecule. So mu is not equal to 0. It is a polar system. Similarly, let us take another example like ClF3. ClF. In ClF3 also or BrF3, there are two lone pairs. And naturally, this is also a non-polar, a polar system. So that I mean to say ClF3, BrF3, IF3. So these are all polar systems. Do you agree or not? Polar system. Now let us take here next case. Next case is I3 minus ICl2 minus etc. If you take I3 minus or ICl2 minus is like this. How many lone pairs it is having, students? It is having 3 lone pairs. This is how it is having 3 lone pairs. So and naturally this is the 3 lone pairs minus ICl2 minus. So it is having a linear geometry. What geometry? Linear geometry. When it is having a linear geometry, dipole moment is equal to 0, and the 0 dipole moment leads to non-polar nature. What nature? Non-polar nature. Another example, XeF2. XeF2 is also having a non-polar nature. This question has been asked in previous examination. So I hope you are very clear about sp3d. Now students, the most rated concept I am going to explain, that is PCl3F2, PF3Cl2. These two systems will work out now. This question is a very rated system. Now there is a rule you have to learn that rule I am going to explain to teach now. The rule is as follows. The rule is as follows. I am going to explain the rule for you. The rule is most electronegative atom should always be in the axial position. That is called Bend's rule. Bend's rule. Bend's rule. So what is the Bend's rule? Bend's rule is most electronegative atom must be in the axial position. Must be in axial position. Axial position. Use this rule. So for first PCl3F2. Students, try to apply. When you apply, you get reply. So Cl, here F is the axial. F should be in the axial because most electronegative than chlorine. Students, in this case, dipole moment is 0. So it is a non-polar molecule. Non-polar molecule. Yeah. Now this is P. Center atom is P. Okay. Yeah. Now let us see the next case. PF3Cl2. In PF3Cl2, P. Students, which is the most electronegative? Fluorine. F, Cl and Cl. Here in this case, it is not symmetrical. Bond moments are not getting cancelled. Mu is not equal to 0 and it is a polar molecule. Mind you, very very important. It is a polar molecule. By seeing PF3Cl2, don't keep all the fluorines in the equatorial position and don't cancel it. It is wrong. This is wrong. This is 100% wrong. F, Cl. This is wrong. This is wrong and this is right, because you have to follow what rule? Bend's rule, or it is also called Dragos rule. Okay, so Dragos, Dragos, Dragos rule, very very important. Yeah. Now let us move on to the next application. Next expression is SF6. Students, if any system is having a regular geometry like octahedral structure, like octahedral geometry, naturally SF6, if there is a symmetry, and naturally it leads to a non-polarity. It is a non-polarity. Dipole moment is equal to 0. It leads to non-polar nature. Similarly, if you take here, students, next one, you can say square pyramidal. What is it? Square pyramidal. If you take a square pyramidal geometry, what happens? Have a look here. Square pyramidal example, BRF5. If you take this square pyramidal, students, here mind you, don't forget there is one lone pair. When there is a lone pair, mu is not equal to 0. It is a polar system. It is BRF5. Yeah. And next, let us take another one. Let us take, students, mind you students, let us take XeF4. Xe is central atom and F4 F4, and naturally in this case what happens, students, mind you, there are two lone pairs, but it is square planar geometry. In square planar, what happens? Lone pair gets cancelled, so mu is equal to 0. In this case, what happens? The bond pairs the lone pairs gets cancelled. It is 0. Mind you here. Now, if you take similarly pentagonal bipyramidal structure IF5, what happens? Naturally, here it is also a non-polar system. The bond moments gets cancelled. So it is IF7. You already did it. IF7. Naturally, mu. What happens to the mu? Mu will be 0, and it is non-polar. And naturally, XeF6 is having one lone pair. XeF6. It is already explained to you. In XeF6, it is having one lone pair like this. XeF6. Do you agree or not? Yes, you must agree. Already explained to you. So this is XeF6 here. This is distorted octahedral. Distorted OH means octahedral. In this case, what happens? Mu will be non-zero because of a lone pair, and it is a polar molecule. Students, this is how you can understand about the bond polarity in different systems. Now, let us see some more systems. Students, have a look. This is dichloro, 1,2-dichlorobenzene. This is 1,3-dichlorobenzene. This is 1,4-dichlorobenzene. Students, mind you, here if you see carbon, this is carbon and this is chlorine. Dipole moment should be towards chlorine. Similarly, this is this side, and similarly, this is this side. So here bond moments are cancelled. Mu is equal to 0. In these cases, mu is not equal to 0. Try to understand. Now, here one important thing is there. Mu is equal to mu1 square plus mu2 square plus 2 mu1 mu2 cos theta. So whenever angle is there, where is the angle? Here there is angle, you can see. Here there is angle, you can see here. So this formula can be applied. Generally mu is inversely proportional to theta. That means when theta increases, here what is the theta? 60 degrees. What is the theta? 120 degrees. What is the theta? 180 degrees. That means so this is greater than this as per the dipole moment discussion. So 1, 2, 3. So this is how you can understand. Now I am giving one very important example, highly rated example, very misleading example. Have a look. Now let us take here this case Cl. Now here you have you can take Cl. You can take here CH3. Here you can take OH and Cl. Let us take this one. Students, have a look here. OH. Have a look here. Now, first case. In which case, what is the order of dipole moment? Very simple. Students, here CH3, let us take it is a standard. Cl and Cl, there may be slight repulsion. Because of slight repulsion, what happens? Theta will increase. This is theta. Let us take this is theta. Here theta will be more, slightly increases because of repulsion. Here there is a hydrogen bonding, theta decreases. When theta decreases, dipole moment increases. So this is 1, this is 2, and this is 3. I hope you understood. So what is the reason here? Here the reason is here, students, the reason is here hydrogen bonding. And this is a standard, there is a repulsion here. I hope you understood. So this is a very rated concept asked in the previous examination. Very highly rated. This is a 5-star rated concept. You must know. Now, let us move on to the next slide. So the next slide is as follows. Students, have a look. Now, let us take some more examples like this way. This is one system, a trichloro system, and this is another system which is also a trichloro system. This is another system which is also a trichloro system. Now, students, this is 1, 2, 3. 1, 2, 3. One second. Let us wipe it off now. Yeah. This is 1, 2, 3. Here some problem is there. We write properly. Yeah. So 1, 2, 3. 1, 2, 3. Trichlorobenzene. 1, 2, 3. Trichlorobenzene. What is this? This is 1, 2, 4. Trichlorobenzene. This is 1, 3, 5. Trichlorobenzene. Now, which dipole moment is maximum, which is minimum? Write the order. Very simple. Have a look. Students, it is symmetrical. Naturally, its dipole moment will be 0. Symmetrical. Dipole moment gets cancelled. Here, the dipole moment is additive. So, it is number 1. Here, the dipole moment gets cancelled. The net dipole moment will be this side. This is equal to this molecule. This question is also asked. Is equal to chlorobenzene. because this is gets cancelled, naturally only this is left out, only this is left out. So this is second, this is second, this is first, and this is third. Dipole moment is 0. So I hope you got a good understanding about dipole moment concept. Now let us move on to the percentage of ionic character. This is what the polarity is all about. I already discussed it. Now, so you know very well, if electronic charge is 1.6 into 10 power minus 19, this one, or 4.8 into 10 power minus 10 ESU centimeter, that means what? That means what? That means completely the bond is polarized. Then only an atom can get the electronic charge. So that's why it is 100% dipole moment. If the charge is less than 1.6 into 10 power minus 19, that means it is not pure ionic. It is not pure ionic. That is the fundamental understanding. So whether you want to know percentage ionic character. So this is the entire atomic distance. Okay. So this is given in coulombs and this is given in meters. So students, if something is given in 1 debye is equal to 10 power minus 18 ESU centimeters. ESU centimeters. This is a very, very important unit. You will understand. So how it will be useful and all. Yeah. Because here 10 power minus 10 is coming centimeter. ESU. Right. Electronic charge is 4.8 into, I do one thing. How do you see? Something dash into 10 power minus 18 is electronic charge. Distance is given in angstroms. That is something into 10 power minus 8 is angstroms. So this is nothing but, sorry, this is minus 10. So 10 minus 10 and minus 8 becomes debye. I hope you understood. This is how you have to know the units carefully. How to convert the units very carefully. Now percentage ionic character is here how much? 1.6 into 10 power minus 19, 1.4 into this is given already. So you got 2.26 into 10 power minus 29. Students, listen very carefully. I am going to explain with listen with a cool head. First of all, how to find the percentage of ionic character. So this is the calculated one. What is the calculated? Full charge 1.6 into 10 power minus 19, distance of separation. How much is you are getting? 2.26 into 10 power minus 29. This should be the dipole moment. So when there is a percentage of ionic character is 100%. But here what happened? Observed is how much? Observed means here he will give the value. 2.6 is given. You are given by the examiner. So only 12% is the ionic character. Now let us see one more question. Simple. If HCl were 100% ionic and would carry a charge equal to 1 unit, so 4.8 into 10 power minus 10 ESU, bond length is given as 1.275. Then what happens? You calculate that. So 4.8 into 10 power minus 10. This is 10 power minus 8. That means you get debye. What is the answer you get? You see that's the answer. You get in debye you will get. So mu is equal to this. What you get here? ESU centimeter is, this is called 10 power 18 is ESU centimeter is called debye. So 6.12 is coming. But how much is given? 1.03 is given. That is observed. Observed is given as 1.03. So when compared to 6.12, so 1.03 is how much? So you are getting 16.83% ionic character. So mu observed by mu ionic. Ionic is the calculated one when it is a full, with the charge is full. Full means what? 4.8 into 10 power minus 10. So you will get the percentage ionic character. Similarly, let us calculate one more. So it is full charge 4.8 into 10 power minus ESU. And 1 point, it is a bond length is given, distance of separation between two atoms. So naturally, this is getting USU centimeters is coming. This is called debye. Well, that is the 7.28. This is the value, is a 100% value. But observed value how much is given? 0.79 only is given. So 10.9% is the ionic character. So similarly, another question, same thing. Calculate the percentage of ionic character with the bond length 0.83. Okay. So observed value is also given, same thing. So you get 3.984 as the 100% ionic character, but how much is the observed? 1.82. You get 45.68%. So this is how you can calculate any number of questions you can solve. So I have given good number of examples. You can have a look. So you can find the percentage of ionic character. So 80% in KCl. So KCl is K plus and Cl minus. So naturally it will be more because 3.0 is chlorine and 0.9 is potassium. So naturally it is ionic bond only. Naturally, that's why more ionic character will be there. So this is also a similar example. Observed is given how much? 1.03. Now you calculate this is E into D. Mu is equal to E into D value. So you get 17%. So similarly you can calculate any number of questions this way. So I hope so you solve good number of questions, so that so you become you get reinforced with the theoretical understanding. So today with this note, so the session on dipole moment is completed. So we'll meet in the next session, the most important topic, that is molecular orbital theory. So thanks for bearing. Have a good day.